Hello, Spark fans, and welcome back to Advancing Spark. That is right, I have returned from my travels afar, and what do I find when I get back but another Databricks Runtime release? So 7.3 is now in beta, so I thought we'd take a quick look, see what's in there, see what new features might help you out, and we'll go from there. So don't forget to like and subscribe if this is useful, but let's have a look what's in there. Okay, as usual, we have a release runtime release notes page, so we can have a look at what are the key features, and I want to show you how some of them are actually working. So what do we have? Key highlights. So Delta Lake going faster. I mean, that's just, we like that. That's a good thing. And this is all to do with that table state. It's all to do with actually how we're caching the latest version of the table. How we work out of all the so many hundreds and hundreds and hundreds of different transaction log records we have, what's the most recent? How do we quickly just get that rather than have to read through this increasingly large number of files in the transaction log? So we've had some optimizations in there, so we'll take a look at that. Clone metrics, great. So if we do a clone, we now get told this is how many files are going across, that kind of stuff. Merge into has got better. So there's a few improvements we can do in there, and that's really, really quite key because there were some key limitations in merge, and they've taken them out, which is awesome. And there's some to do with when you restart a stream, being able to choose how it actually works. So a few nice things in there. Okay, so that first one, that data lake optimizations, we've got these enhanced checkpoints. So let's just dive into that actually. So we have this thing. So we talked about that in the past, in that if we're doing lots and lots and lots and lots and lots of changes to a delta table, then we'll see all the little JSON files made, and then every 10 or so currently, we'll get a little Parquet file made. So it's, again, SQL Server parlance. If we're doing lots of small transaction logs, occasionally do a full backup, and that's kind of your, I don't need to go back and read all the previous transaction logs. This is my checkpoint. I can go from that main log, and then I just need to top up any logs that have happened since then. And that's what we're doing with those Parquet ones. So every 10 or so updates to a delta table, it'll still create all your JSON ones, but it'll create a Parquet file which rolls all those changes up. So this is the current state, and then you can go from there. So let's go. And that kind of, there's some optimizations essentially that they put in. So it used to still do that. So 7.2, you'll see it still does some checkpointing, but essentially they just made it better. They've made sure the query engine picks it up. I'm trying to do a quick example of actually seeing that in action, seeing that working. So I've got a quick thing in here. So I'm using the new runtime. So this is on runtime 7.3. And let's just run through. So normal, super quick example, creating a blank delta table. So if I just go back over here, I should be able to see I've got a blank table, so I've got addresses, got no data in there, I've just created the delta table. I've got my transaction log saying nothing's happened. So little starting point. So a little quick thing to say, just run this like 51 times. I'm just inserting a blank record, but just forcing it to do it lots of times. So rather than just trying to create one record set with 50 records, and that would commit as a single transaction into my delta log, I'm forcing it to do 50 odd separate transactions so that we get all these different inserts into the delta table. Okay, so we can see it's piling up, doing tons and tons of different jobs, going nice and quick. And then if we go and have a look at what's happening over here, so back in our addresses, we've got all these separate individual Parquet files. So remember, you can't update an existing Parquet file. So if I do an insert, it has to create a new file. So I've got all these little individual Parquet files, awfully inefficient because they've just got one file each. And then if we have a look at what's happening inside our delta log, so we've got all these different transactions. Every 10 or so, there we go, we see a checkpoint.parquet. It's rolling up the details of the previous one. So next time I come and read from this delta table, I don't need to go back and read all of the previous ones. I can just go latest checkpoint and then get any from there. So just optimizations to make that stuff go quicker. And what you'll notice is when you're doing this, occasionally you'll see this command. So it's running things and you see updating the delta table state. And anytime it's doing that, I always thought that that was just to do with writing to the transaction log. That's not. That's actually updating the cached version of the transaction log that's held on my cluster. So anytime it's doing that, it's kind of just pulling that back, saving that, doing the stuff it needs to, pulling it back, saving it. And that's one of the things that can be optimized as well. So occasionally, if you had a really, really long pile of transactions in there, that updating table state would take a little while because you just had to read each and every little transaction file and pull it up, and it wasn't making full use of the checkpoint files. Now it is. It's going a lot faster. So it's just generally a little quality of life thing. It's going to go faster if you're doing lots and lots of small incremental updates to a Delta table. And especially if you've got a Delta table that's been live in prod for a year, then that's going to be nice and optimized. We're not going to have to go back and worry about the state of that transaction log over time. So nice little change. Good to see. It's very, very useful. It has some limitations with structured streaming, and you can turn on certain settings. But for the majority of stuff, if you're doing batch style updates, great. It's going to work. Happy. Right, clone metrics. So we can actually carry on with that little example. So we have that. Have a look at the history that we had in there. Again, we'll see a load of stuff happening inside my Delta table. We can see all my different things. Now, there's nothing in here which tells me that that checkpoint was created. So all I have is essentially just a load of things happening in there. And then after that, so we can do that. The clone example that we had from previous session, we can say, you know what, go and update that. So essentially invalidate those 50-odd awkward, annoying little pocket files, update them. So it's kind of gone through and done an update. We can do describe detail and just say, well, how many files am I now dealing with? So remember, I had 50-odd files. I've now got 8 files. So actually, I've ran an update statement. I've said, these are now all logically deleted in my transaction log. The only active files are 8 new Parquet files that encapsulate all those changes because I've got 8 nodes, 8 slots on my cluster. I've got 8 CPUs. And I'm creating these 8 new Parquet files. So that's fairly straightforward. And then if I do a clone, so I'm going to create or replace a new table. I'm going to shallow clone my existing table. I put it into a new place. And then we can just test and see what that looks like. Because previously, if you cloned, you didn't really get any information about where it was coming from. You didn't have any metrics captured in your transaction log. And that's what this update is. So if I do that, I can say what's happening inside my table. Go, so it's written to my table. I've got my clone record. So I had a thing saying I've cloned. But that's all I had. I didn't have much additional information. All the update is saying we've now got these operation metrics. So I can see that the source table, the table I was cloning from, that I'm now detached from, how many files did I have? So the same for shallow or deep. I'll get some metrics just telling us what do we actually sort of source, what's happening in the original source table when I created this clone, just so we've got that baseline information about what's going on. So kind of useful. Again, just creating consistency. So no matter what metric I'm doing, no matter what action I'm doing, whether it's an update, to delete, whether it's a clone, whether it's an optimize or a vacuum, it'll put something into the transaction log saying, this is what I've done. This is the information about doing it. So if we need to do some reporting, if we need back some lineage, if we need to do some auditing, we've got that information captured inside that trans log. So that's just a consistency update just to make life a little easier. Okay, merge into. So that is fairly big. So the merge now supports any number of matched and not matched clauses. So that used to be a limitation of the merge into. So if you're saying, okay, I want to merge this change set into my main table, but if it's that column that's changed, then I don't want to make the update. But if it's that column that's changed, I do want to do it. So it's like if it's just a system audit thing ticking up and no actual data's changed, don't bother merging that in. That's just effort. We don't need to. And if you had multiple clauses like that, it wasn't possible. So you'd have to break it into several different merge statements, and it was all very, very annoying and awkward. So now just saying, okay, we can have a sophisticated merge statement that has several different clauses for, in this type of merge, when this matches and this doesn't match, but this does match, do this action. In this situation, do this separate action. So we can be updating just specific fields. We can updating the whole thing if it's this kind of change. So that just means we can do it a lot more easily. It's a lot more sophisticated. We can reduce the amount of code that we have. Rather than having to have lots and lots of different merge statements, we can have a single, more complex merge statement that covers all the different eventualities we need to be covered by the update that we're doing. So super, super useful. And that was always very annoying. Unconditionally deleting rows. So just saying, look, if it exists in my source set, just get rid of it. This is my list of stuff I want to get rid of it. And you had multiple in that list, it would throw an error. So you'd have to kind of do dedupes and then pass it a delete list, which then means you have to do that as a separate merge clause. And now we can just go, like, if it's in this list at all, just make sure that's deleted and then apply the updates and all that kind of stuff. Just, again, simplifying the merge operation. And if we're starting to rely on merge as one of our main update mechanisms of getting data into a Delta table without having to worry about any of the complexities and any of the performance constraints, that's just making our lives easier. So merge into getting a lot better. I'll probably do a merging video at some point soon just to talk about actually some of the patterns that are good for that stuff. And the final one I want to kind of point out is this initial position of streaming. So if we're streaming from a Delta table, and we're just saying, like, just copy from that Delta table. Whenever there's new data going in there, I just want to have a separate process copy from that table as if it was streaming data and just put it somewhere else. And doing that when you kind of previously did that on a Delta table, when you first start that job, it starts at the beginning and trawls through the entire table. Now, you might have a checkpoint, in which case it would kind of just ignore the changes that have come since. It's fairly annoying of having to build that mechanism and trying to have that working. So being able to say starting version, starting timestamp, we can actually say can I just get the history of changes from this point in time and then stream it over here as a mechanism to be able to control where we're moving things around. So if we're doing things like, there was a client recently who needed an offline history, an asynchronous history tracking. So something like slowly changing type 2, right? We want to say, I want actually it's more type 4. Want my current state of the table, and now a history table. So a version of this table where we're not relying on the Delta kind of transaction history, which has a lot of redundant writes. We're tracking a huge amount of data. We don't want to use that temporal querying for our history tracking over several years. So instead, we want to track another physical table and do change tracking on each record. So this record has an effective date. So from this period to this period, this record was active, whereas from this period, this record was active. Visual Kimball style stuff if you need to do it. And we'd have to build something previously there, which is at the point we're inserting into that main table, a separate insert of the same data that does a historical merge kind of thing. And that's, it's just annoying. It means it slows down your ETL, right? It means you're waiting for that history to finish before you can move on to the next job. Whereas if we're streaming from those Delta tables, we can have an asynchronous job. We can have something else that kicks off, looks at that Delta table and says, what's changed since I last worked? And then pull out any change records and then apply those changes separately. And that's pretty powerful. And that kind of nice mechanism, this is just giving us a bit more control about it. So if we wanted to say, get these versions, don't get that version, only get versions that have happened from this point, create separate tables that have change tracking, which again, we could use shallow clone forms as well. It's just a little bit more power to be able to do some of that stuff. So there's some nice better patterns for enabling things like history tracking, change detection, slowly changing kind of stuff that we can do based on Delta through streaming in a really neat little way. So that's really cool. So some other stuff in there, some articles to write, some Spark submit jobs. I admit I don't do that often. Most of my work with Databricks is to do with deploying things in notebooks and calling wheels and things inside the notebook, but I don't tend to use Spark submit. But it is a nice idea that actually, if you're writing a lot of data to a Delta table, you can now do it via multiple clusters at once. So you can say, well, actually, use all these different clusters and write data into the same table with transactional guarantees on there. So that's very, very cool. Don't know how much I'm going to be using it. Upgraded S3 connector is generally available, so making things better. Again, I'm living in Azure land. Don't know how much we're going to see that. One thing forward is autoloader. So if you're on an older version of Data Lake Store, if you're using Data Lake Store Gen 1, then you can now use a directory listing mode on top of it. So you can actually sort of be pulling data a little bit more efficiently from Data Lake Store, which is cool. And there's some things like there's a few people having problems with if you're reading from text or binary files, there's a few issues in terms of actually having to give it a schema, whereas you don't know the schema because it's text. So they kind of improved that. So that's kind of a little bit neater in terms of pulling data across. This one I know several people have been very happy about. So Azure Synapse Analytics, the provision SQL pools side of things. So what used to be Azure SQL Data Warehouse, inserting data into there, if you had any var binary, it would automatically set it as a max and just fail. So essentially, you couldn't insert data into a new table if you have certain data types, which isn't very good. So it's basically just oh yeah, you can't use the connector if you have certain data types. Now, again, how many people have var binaries? What a lot of people have binary types, actually. You wouldn't necessarily have a var binary in your database, depends on what you're trying to do. Essentially, you'd have to do various casts and manipulation of your data frame before you can insert it into SQL Data Warehouse. Whereas now, actually, they've fixed it. That's good. We can just say, take my data, get it into that provisioned Spark SQL pool, and not have to worry about some of that stuff. And they're for me, they're the main things. So there are some other bits in there. It's kind of good to have a look around. Again, we've got the normal upgraded libraries. So another Koalas upgrade, which kind of there's a lot of focus at the moment in terms of improving compatibility and improving the coverage of Koalas. And another update to PyArrow, and then a load of bugs fixed, the normal stuff. So I recommend having a look through them. May well be certain things that you've had to build workarounds in the past that are now fixed in this runtime. Main thing for me is those Delta updates and the improvement to merge. They're the pretty big things that I want to see. So that is our new runtime. There's lots of stuff in there. Again, it is currently in beta. Only expected to be in beta for a couple of weeks, the way that Databricks tend to work. But again, recommend giving it a try, having a look. There's no major paradigm shifts in terms of how we work. But actually, I'm going to be looking at merging and taking a lot of my existing code, factoring that down, and just making that a lot more sophisticated. So let me know how you get on. If you have any interesting ideas, if that merge statement changes how you work, if the updates to structured streaming, actually you're looking at going, wait, there's a lot more in that than we're thinking, then let us know. Drop down in the comments and let us know how you get on. Otherwise, we'll see you next time. Cheers.